Hello everyone, welcome to a tutorial in random forest classification. Today we will focus on random forest because two other methods for classification by using machine learning has been done. One in support vector machine and the second in naive Bayes classification. All right, in today tutorial, uh, we focus on random forest. It is an ensemble classifier that consists of many decision tree and output of the class, that is the mode of the class output by individual trees. So I would like to say that a random forest is an extension of decision tree classification. Instead of using only one single tree, random forest consists of a set of individual trees. And this method, firstly introduced by Tin Kam Ho in 1995, and can be combined also with bagging idea for random selection of feature. Here we have the algorithm for solving the classification using random forest. The first the first step is for each tree. After we build our tree, so for each tree, we choose training data subset. So it is some kind like splitting the tree into two subset, left and right. And we can stop the condition hold at its root if, for instance, uh, there is no any more features within the dataset can be classified. Otherwise, we can continue by build the next split. So in the next split, we have several stages of computation, which the most important stage is the computing of Gini index. The Gini index is a measure of how much we can get more or extra information after for instance, if we continue to split at that point of splitting. So that is some kind like a signal whether we should pursue doing further splittings from a such of point or not. So we we use this Gini index as a some kind of like decision signal whether we should do further splitting or we should stop and doing and prune such nodes or such uh, branch. We have several terminologies here. Root node in our decision tree is the first nodes. It is a parent node. We can call it a parent node here. And we have a splitting, means we split into two, sunny and rain, or maybe overcast. And decision nodes mean can be humidity, can be windy, and leaf or terminal node can be yes or no here. And pruning, if we stop the leftover nodes because we would like to pursue such branch in our tree. For instance, here we prune rain and we go further to we focus our investigation just at sunny nodes and below. And we have a branch and subtree. Branch is a set of tree and nodes here, and we have parent and child node. Here we have parent. This is child node. Here is parent. This is child node. All right. That's the terminologies we could introduce for random forest classifier. And let's go back to our Gini index measurement. The Gini index measurement is a measurement to find whether we can get a further information, we can get more information if, for instance, we uh, do splitting at that certain point. And it's a function of three some kind like three index. First is the parent index. The second is uh, left side or left left side. Yeah, the one this left branch index and right branch index. Sorry, here. So measuring Gini, we start with the root node. So to fully specify this node, uh, we need to split the data set into two daughter nodes. So that's why left and right is like some kind of like daughter nodes. Nodes in the left, nodes in the right. So here left and right. This is left node, right nodes. So and we can call it as a daughter nodes. The way in which the data set is split at its node is the main aspect that categorizes the tree we are building. Uh, the IG here is the information gain that in our case, we calculate the information gain or IG uh, to uh, to find a split point that maximize the information gain. And here ID, uh, we can call it the Gini index or entropy. And P here is the probability that a random pick from all elements in that node is a member of that classes. So, all right. Yeah, from this point, we can continue our work with looking at a list of program that I have prepared for this session. Okay, where is the okay Anaconda? All right. Now we can continue our lesson by studying the Python code for random forest classification. As usual, at the first stage of our code, we have to get data from outside. In this case, we are using NumPy as a library, and as usual, we use the same two lines, lines 8 and 9, to get the data from CSV file. And here we define an equation. Oh no, sorry, not a function. It's called forest. It is a build forest with three different parameters. Train, it is the data we get, and k is the number of sample we take from the data set for each tree. So for each tree, we we took from the data set 10 10 numbers of row. And entries means the number of trees we would like to build. Here we have 100 trees uh, for solving our classification problem. And the objective of our main function is to print or sorry, to calculate the accuracy of the computation, and to print the prediction of the of the uh, of the class within the data set and the actual class within the data set. So some kind of like one-to-one comparison. For instance, at row number 1 or row number 10, whether the class of the row is correctly predicted by the random forest classification. And the next function is the function about traverse tree. In this traverse tree function, we would like to split the parent nodes into two, left and right. So it is some kind like just a splitting function, a function to split the data into two, right, left and right. And the third function, it is some kind of function to make a prediction. It is some kind of like to compare between the class of the result of the final column of each row with the prediction from the random forest. So, for instance, let's open the file that we would like to analyze. Here we have Python data file for class Excel exercise classification 2. All right. Now we are on the in our screen. We have a Excel file, the data from Excel file data that we would like to analyze. Uh, we have 7 independent variables, x1 to x7, and 1 dependent variable, y. So here y is the class that we would like to classify x1 to x7, whether it's can be categorized into x minus 1 or 1. Minus 1 and 1 can be anything, can be yes or no, can be go no go in manufacturing processes. And here we have the traverse tree. The traverse tree means to split, to divide the data of each rows based on rows into two different nodes, from parent nodes to two daughter nodes. So, for instance, if we split at index or row number 20, for instance, so in the left side, so from row number 0 to row number 19, we will categorize, we will put into a left side nodes, and 21 above we will put into the right side nodes. So that's the traverse node. So we would like to split the data into two parts, and then we would like to make prediction. And in the prediction, list of classes is firstly it is empty, because we would like to put left and right uh, according to the previous traverse tree function splitting. And then we calculate the information gain. Here the information gain, as we have already explained before, to measure the value of, or not the value, but the amount of information that we could get by choosing such a splitting point. So information gain as our function here is a function of the parent Gini index, and then left node's Gini index and right node's Gini index. So after we split the parent nodes into two, left and right, and then we would like to calculate how much the Gini index of the parent, how much the Gini index of the left side, how much the Gini index of the right side. And the calculation of the Gini index of the left nodes and right nodes we can use two different measures. First is a Gini index and the second is entropy. But in this lesson, we will use a Gini index instead of entropy. So the equation for calculating the Gini index is 1 minus the summation of probability, a square probability of its classes. So classes here in our data, it is minus 1 and 1. So here we split the data into two, and then we calculate according to class 1 how much the Gini index of the left side, and according to class 1 how much the Gini index of the left side, and we sum together those two Gini index left and right, and the summation uh, we should choose and we should uh, not we should choose, but we should combine those Gini index of the left side, whether it is class minus 1 or class 1, and the combination of those two summation, we call it the total Gini index for the left side. So if we, for instance, notice, or after the computation, we notice that the Gini index of the right side, for instance, after we split 21, sorry, so 0 to 20 row number 0 to row number 20 is categorized into left side, has a lower Gini index than the Gini index of the right side, which is the Gini index of row number 21 to row number here we have 398 data. Then we should go further into the right side, and we prune the leaf or the nodes of the left side. So in that case, we go further into the right side nodes, and yeah, this is the, yeah, ij means the information gain. The function is coming from the calculated Gini index function. Here we have a calculated Gini index function. So the equation here is exactly the same as our equation posted in this presentation. All right. Now we continue to the next function. We call it as split nodes. Define split nodes. Splitting a data set involves iterating over all rows in the data set, checking if the feature value is below or above the split value, and assigning it to the left or right group respectively. So in split in splitting the nodes into two, it is some kind of tedious jobs, and can, if the number of trees are less, those tends to be some kind of overfitting. So it is not for instance, overfitting, the risk of getting overfitting is that whenever you have a new data coming from outside and you would like to test your random forest using the new data, the error will be increased. So in this case, uh, we are using a random forest classification with many trees in order to avoid the overfitting. The feature of on which to split is chosen randomly when building a random forest. So to find the value on which to split, we have to go through all possible splits and evaluate the information gain. This can be a very expensive calculation. So in our approach here, we pick all possible values of the feature within the training dataset and evaluate the information gain for all of them. In that case, the cost will scale the number of rows in the training dataset. So for instance here, uh, if for instance we would like to split the data according to feature number 1, for instance x1, then we can choose starting from which rows we should make a splitting. Or maybe we can split according to feature number 2, x2, x3, x4, and therefore in random forest we split all of this feature so that we could get a very minimal error in order to make a decision whether such a data in each row categorized into +1 or -1. All right. Now we can start making our tree building. In tree building, we need to implement the following consideration. For instance, how much the depth of the branch we should pursue, and how much the minimum size of the data within each branch or within each step of splitting here. So we have to implement the following step. First, we have to randomly determine the first splitting feature. So which among these 7 features we should split x1, x2, x3, x4, x5, x6, or x7. And after making a decision which feature we choose for the first splitting, and then split the original data set according to the first optimal split. So here we have get splits, mean we did we make a decision after we determine which feature we would like to split, and then we would like to choose within this column of feature, for instance x1, if we choose x1, which splitting point we should go further in order to maximize the information gain. Right? And then we recursively repeat uh, step number 1 and 2 and until the tree has reached the maximum depth, or either left or right group of rows is smaller than the minimum number of rows. So in other words, whenever the number of right or left groups rows is less than the minimum number of rows within one one baking or one sampling, that indicates that our splitting process should be terminated. So here we have this split definition function to do that. And the final function of our random forest classification codes is to define a function to build the forest. So we should define how many the max depth in our in one branch or in one node, in one branch in our tree, and how many the minimum size. So if for instance the minimum size here is also 3 or 4, and sorry, yeah, minimum size is 2 here, for instance 3 or 4, means if the leftover rows under evaluation is less than 2, for instance one row left, then we should stop the 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 splitting. Means if it is only single row left, then we should stop the splitting here. And then for us with under bracket means at the first step of the computation, we do not have any data inside the trees. So that's why it is just bracket without any number inside. And we could start this computation. Yes, we have here 96.23% of accuracy. And for each rows, we have also printed the comparison. The actual means the data for training is -1, but we predict as a 1. It's a mistake. But it is only at the last row. But second, the, after the last row, we could predict accurately. Also the third, fourth, and fifth, even sixth. But at the seventh row after before the last row, we also made one more mistake. So in conclusion, the accuracy of our prediction is about 96%. I don't know whether it is sufficient high or not, but if we would like to make it better, we could do some kind like this. Either we could increase the number of data, or we could increase the number of forests to trees, which means we add more trees, so as to make some kind like more refinery about the data. Okay. However, doing this kind of random forest classification from scratch is really a tedious job. And in the next video, I would like to show you how to do this computation a bit easier by using a special library for machine learning. We call it sklearn classification. Oh no, it's called sklearn library. Using those library, you can do some kind like classification, regression, and then you can data reduction, and even you can use the library for making some kind like you will have many more tools in data mining inside the library. So yeah, I think we can stop this video at this stage, and next video will be focusing on using the sklearn classification. Sorry, sklearn library. Okay, thank you and goodbye.